So, let's get right into it. What if you could build a completely automated YouTube factory right on your own Mac and have it cost you literally nothing to run? Well, today we're going to break down the HLN machine, a real-world experiment that did just that.
You know, we all kind of want it, right? That one single magic AI button. You press it and poof, it handles everything. The writing, the directing, the editing, the whole shebang. It's the ultimate dream of anyone trying to automate content.
And that's exactly the challenge that the HLN machine was built to solve. The mission was simple on the surface. Take one single news article and turn it into a complete YouTube short. But here's the kicker. It all had to happen 100% locally on a single machine with absolutely zero running costs.
But that brings us crashing right into our first major problem, the myth of that perfect button. See, the issue, as it turns out, isn't really that AI is failing us, it's that we might be completely misunderstanding how to build systems with it in the first place.
This slide really gets to the heart of the matter. You've got two paths you can go down. On the left, there's the magic black box, this stream of a single genius AI that just does everything. But you know what? In the real world, models fail. They make things up, they get stuck. So HLN chose the path on the right, the understandable white box factory. It's a system made of smaller, cooperating parts that, and this is the most important part, you can actually look inside and see what's going on.
So let's pop the hood and go inside that white box factory. This is where we stop thinking about magic and start thinking about manufacturing. We're going to see how an understandable, debuggable system is actually put together.
Okay, so this diagram gives you the 10,000-foot view. The HLN machine isn't one giant AI brain. Nope, it's an automated factory that has 4 totally separate pipelines. Each one has a very specific job to do, and they all work together in a neat little sequence.
And here are those 4 assembly lines. First up, the build news story pipeline. It takes a raw article and turns it into a script. Then, the build videos pipeline gets to work creating all the visuals. After that, branding and subtitles adds all that final polish. And last but not least, the upload pipeline packages it all up and shoots it off to YouTube. It's simple, logical, and each part minds its own business.
But what's the glue that holds all this together? Well, it all comes down to one absolutely critical file, IR.json. You can think of it as the factory's central nervous system, or maybe a master blueprint. It's basically a stable timeline that holds every single piece of data for every sentence, the text, the decisions on A-roll versus B-roll, even the unique IDs for all the assets. And if we zoom in a little bit, you'll see that every single asset, the audio file, the video clip, the subtitle for a sentence, is named with something called a dependency hash. What that means is they're all linked by unique code. This makes the entire process traceable from start to finish. If something breaks, you know exactly which part of the assembly line to go check. Okay, now this is where it gets really interesting, because this brings us to the first major lesson learned from building this whole thing. They basically had to fire their AI director. Why? Because letting a big language model make creative editing decisions all by itself, well, let's just say it's a recipe for absolute disaster. At first, the approach seemed obvious, right? Just ask the AI, hey, where should I put the B-roll? But the problem is, an LLM is designed to optimize for making sense, for semantic coherence. It has absolutely no concept of rhythm, or timing, or the kind of visual pacing a human editor instinctively understands. It just doesn't work. So instead of just relying on some vague AI vibes, they gave the system a physicist's brain. It actually calculates the semantic energy of every single sentence to find the peaks, those moments that are just packed with the most information. You can see it right there in the graph. Those high-energy spikes, that's where you put the B-roll footage. It's brilliant. And this all led to the creation of a totally new metric they called the Visual Significance Index, or VSI for short. It's a calculated score for every sentence that represents, and I absolutely love this phrase, how badly this line wants images. It's a combination of that semantic energy we just talked about and a linguistic analysis of how visualizable the words actually are. Right, so the system now knows where to put the B-roll. The next massive problem is what to show. How do you avoid getting that surreal, totally useless AI-generated art and instead get something that feels like actual editorial footage? Well, the answer, believe it or not, was to make the AI blind. So check out this incredibly clever multi-stage pipeline they built. First, it pulls out simple keywords, these editorial atoms, like company names or places. Then it goes out and grabs real-world images from Google to use as reality anchors.
After that, a vision language model looks at each image and describes it in plain text. And here's the magic trick. A different LLM, which is completely blind to the actual images, then chooses the best one based only on those text descriptions.
And honestly, the results are just night and day. On the left, that's what you get when you just ask an AI to make a video from a text prompt. It's surreal, it's abstract, it's art, I guess. But on the right, that's the output from the reality anchor pipeline. Yeah, it might look a little cursed, but it's grounded, it's relevant, and it actually feels like something you'd see in a news report. So let's talk about reliability, because LLMs are incredibly powerful, but sometimes they can be like this super creative but unruly intern who just loves to ignore your instructions. And this became a massive problem for critical little tasks, like fixing subtitles.
Here's the problem in a nutshell. You give an LLM a really simple task. Fix a transcription error, like turning 5,000 set of your back into $5,000 a year. But instead of just fixing the words, the LLM will often go rogue. It'll change the timestamps, it'll merge two different lines together, or it'll just completely break the JSON formatting you desperately need to keep.
So the big takeaway here is, you can't just trust the intern. You have to build guardrails around it. This system uses 3 distinct layers of defense to manage all these LLM errors and keep the factory running smoothly, even when one little part decides to misbehave.
Let's break those down real quick. First up, layer 1 is an internal check and retry. The script itself checks the LLM's work, and if it's wrong, it literally tells the model, hey, you messed up, try again. Layer 2 is a pre-checkpoint restart, which just automatically reruns the early, cheaper stages up to 3 times if something fails. And finally, layer 3 is a quality gate restart. This is where the final video gets checked for basic things like, is it long enough? If it fails, the whole process gets kicked off again from the very beginning. All of these lessons, all of these challenges and solutions, they all lead to this one really powerful conclusion that pretty much defines the entire philosophy behind the HLN machine. This slide just captures that core idea perfectly. It's what they call the white box principle, and it means every single part of the system has to be traceable, interruptible, retractable, and replaceable. The goal isn't to build some flawless magical system, the goal is to build one that you can actually understand.
So, if there's one thing to take away from all this, it's this. The future of building things with AI isn't just about getting better at talking to the models or about writing some super clever prompt. It's about building robust, understandable, white box systems around them. In other words, engineering is the new prompting.
And that really just leaves us with one final, big question to think about. As AI gets more and more powerful, which path are we actually going to choose? Are we going to keep chasing the shiny allure of these magic black boxes that we can't really control or even understand? Or are we going to do the hard work of building understandable, inspectable, white box factories?